the second video in our 2020 Wasatch Wildlife Watch training series. In this video, we're going to talk all about the past results from 2018 and 2019. We haven't actually analyzed the data from 2019, so all this stuff you'll see is from 2018. But we feel like it's really important to show you the results of all this data that you're gathering. All this work that you're putting into this project is going towards something, and it's going to make a difference in our community. And so we would feel like it's really important to show you what difference it's making, show you the type of information that we're gathering, and really just know that your contribution is what makes this type of work possible. We can't thank you enough. And so let's just get right into it. This video is all about past results from past projects. And so the first thing I want to show you is our spatial mapping. So what we're able to do with the data that you gather is produce maps of high habitat quality for each species. And so what you see right now is a habitat map for puma or mountain lion, whatever you want to call it. And so if you look at this map, all of these blue dots, these are camera stations that were active during 2018. Every camera station that has any type of yellow circle around it, that is a camera station that detected a mountain lion during the 2018 field season. And you'll notice that some of the circles are a little darker than others. They're a little easier to see. Those directly correlate with the estimated relative abundance at each one of those sites. So the darker the circle, the higher the relative abundance was, and the better the habitat quality was at that site for mountain lions. And so basically what you're seeing here is what's known as a kernel density estimation. This is basically just overlaying all of the detections and seeing if there's any correlation spatially with where those detections are. And if it is, it'll sense that and start highlighting the most important habitat. And so you see for Red Butte, our really important habitat, or for cougars, sorry, our really important habitat is in Red Butte and kind of in the adjacent canyon. So this is Dry Creek and City Creek, and that is really what's showing up on this map is vital habitat for mountain lion. But we can also see that there's some really important habitat in the upper elevations of Mill Creek and Big Cottonwood Canyon that extends into Little Cottonwood. And so we can kind of get a good idea of where mountain lion are found in the central Wasatch based on this data right here. And what's really interesting about this information is you can really start to get an idea of where potential pinch points are or areas of habitat fragmentation. And even if I just draw a line across I-80 here, it, I hope, becomes apparent to all of you that there definitely seems to be some type of an effect there. And in fact, we will go into that in a little bit later on in this video, but I-80 does seem to have some type of effect on a lot of the different wildlife species that we're doing. And so basically this is one of the tools that we're able to use and able to develop from this data. And what's really great about this is we can identify these high relative abundance areas. These are areas of extremely high habitat quality. These are areas that are vital for cougar conservation in the future. But we can also identify areas of low relative abundance, areas where cougars are found, but not at super high numbers. They're not blowing up on our map here, but that doesn't mean that they're not important. And they could potentially become more important if they could be connected to these other areas of high importance. If we can facilitate some type of corridor connectivity between those two areas, that might be able to facilitate increased dispersal, might be able to make these areas light up a little bit more in future maps. And so one of the big things though that comes from this, and one of the things I'm most excited about, is identifying important core habitat for each species. And so what you're seeing here is down here is a probability map of core habitat. This is habitat that's vital for cougar conservation. And we can see that this high probability estimate is the area where it is most likely incredibly vital that this habitat is protected for cougars. And so we can see that when we blow that up, it's a large proportion of the central Wasatch range of our study area. That should make a ton of sense because that's where cougars are mostly found, especially in the summer. On the flip side, we can also identify non-critical habitat, which is highlighted by the polygon that basically incorporates all the sites in the lower elevations and then the Salt Lake Valley. These sites we can say with quite a bit of confidence are not super important sites for cougar conservation. And if continued development needs to occur, potentially in these areas right here, they might be a good spot if you're trying to protect cougars in the future. And so we can do this for all of the species that we have. And what you'll find when you do this for every single species is you can do individual areas of management interest as well as community areas of management interest. And in this case, this is a cougar management interest area where we have these two important core habitats that are what looks to be broken or fragmented by I-80, or at least that development in that area. This means that this is a potential area where a small amount of investment could prove to be vital for cougar conservation, could go a long way. Because if we could connect these two areas and make them one large core habitat or one large area of high relative abundance, these smaller areas, these other areas where it's not as important for cougar conservation, they can potentially be more developed in that instance. If we can facilitate movement from Red Butte into these other areas, then that is theoretically increasing the total amount of area for cougars to roam, which means they could then deal with a little bit of development in these other areas. So this is basically when you overlay a few species on top of each other. This is actually just looking at presence and absence data. So this isn't that relative abundance. That is a very data intensive measurement, and we can do that for each species. But we can also just look at where species are present and where they're not. So just zeros and ones. Were they absent or are they not? And so this is a map that if you overlay all of our carnivore species and just their presence and absence on top of each other, this is the map that is produced. So you get these really nice core habitats that we see right here that are fragmented in spots by what looks to be pretty simple to delineate areas. And so this is opening up the opportunity for wildlife managers to say, okay, this is how, if we want to protect carnivores in the future, we need to establish some type of connectivity in this area, some type of connectivity over here. They can start identifying these areas that are most important in the future. And, you know, more and more data, the more and more years we get of this, the more that's just going to facilitate and really harden these areas of important habitat for all these different species. But what you'll also notice here is that Red Butte sticks out like a sore thumb on every single map. And that is simply because Red Butte is a super pristine, untouched area. It gets a lot of wildlife, and it's really kind of the source population for a lot of the species that we are seeing in our study area. But because of that, it makes all of these other areas look a lot less important, when in reality, they have a lot to say about what happens for the future of the Central Wasatch. And so if we want to identify what's going on in those areas, we can zoom in on, let's say, this section of the map on our southern canyons. We can pull that up, and these are the important areas for these southern canyons. We see that there's actually quite a bit of connectivity between these three canyons as far as our carnivores go. It looks like the carnivores are fairly adept at navigating those higher elevations. But let's say we wanted to dig even deeper and look just at the cottonwood, we could do that as well. And these really nice paths start to show up and are really clear for us. These are vital paths for conservation, paths that need to be protected in the future. So this is just one of the tools that we've developed using the 2018 data, which, if you remember, is actually the data, the year where we have the least amount of data. So I can't imagine to see what, I can't wait to see what happens with 2019 and 2020. All right, so this is just kind of one more of those. This is the actual relative abundance estimate, the estimate that's a lot more difficult to get. It requires a lot more data. If we do this for all 13 species and overlay it on the entire study area, this is the map that we get. Once again, Red Butte really blows up as an area of intense importance for the Wasatch. It's really just vital to this ecosystem. But we also start to see that it gets really dark around the I-80 corridor, and we see the darker colors are lower habitat quality. And that is really telling us something about I-80, that it is a major source of habitat fragmentation. Just looking at this, we see this nice patch of habitat really all the way out throughout the southern canyons. And then we see this really nice area in the northern canyons, and there's this just stark difference right there at I-80. And so that's a major source of something that we're looking into right now, is how to potentially facilitate, some dispersal between those two populations. I know a lot of you have heard of or seen the wildlife overpass. We're actively monitoring that, and we hope that that might be enough, but we never know. So that's why we have to continue to produce these types of maps to see, as time goes on, do we start seeing a more uniform color here? Or do we still have this buildup right here because they're not able to get to the south? So this is just another way to visualize kind of that same data, just more in a graphical form. So these canyons are organized geographically as they would appear. Of course, Salt Lake doesn't appear after Little Cottonwood, but for the canyon's sake, this is how they would appear. And I think the major thing that sticks out is just how important Red Butte is to the persistence of wildlife in our community. Red Butte Canyon, many people have never seen it, never gone anywhere near it. And so they don't realize that it's there, but it is facilitating so much of the dispersal of what we see throughout our entire wildlife community. And we can even see that it might even be having a spillover effect on its adjacent canyons, especially those ones without housing density. But what we see is, if you can imagine I-80 being right here, you just see a stark drop off once you get past that corridor. And that's something that really worries us. We have this really nice community, especially north of the interstate, and then it really drops off quite a bit. And this is something that you wouldn't be able to notice if you didn't have this comparison available, because we still see a ton of wildlife in these other canyons, but compared to what we see in the north, it really is no comparison. And that is important for us to be able to note, because this is a problem area for us. These should theoretically all be the same. Much of the habitat in all of these canyons is very similar. We have scrub oak in the foothills that goes up into more coniferous forest as you go higher in elevation. And this is kind of basically the entire habitat for the Wasatch in general. And so to have this difference just between canyons is pretty stark, and I think shows a good example of what human development can do to an area if it's done without any type of conservation measures. All right, so then moving on, this is a measurement that was taken directly from the citizen scientist, so directly from you on the ground when you were filling out whether or not you saw human activity present or absent, and you were thinking, why is this important to gather this information? This is your answer, so that we can look at things like, how is the community changing as we go from an area that has trash present to an area that doesn't have trash present? Those type of things that you are gathering, we can then standardize those measures and plot them against something like species richness. So this is the estimated species richness at each site in 2018. Every single one of these dots is an estimate from a site, and these development indexes are measured by you, the citizen scientist, at the site. And what we see is a really nice trend. It's not a trend we'd like to see, but we see that it's a clear trend downward of species that visit a site based on how developed it is. And so this is a very clear sign of what's happening in response to the site level development, the development that's going on right at the ground, at the actual camera itself, not using any type of map that has a really large resolution. This is at the site itself, the little things that can affect what we see. When we look at that in a different way, we can measure it based on a community similarity index. So what this is saying is that basically this is a number from 0 to 1 that represents a fraction, and this fraction is how similar a community is to this dot right here. This is the Red Butte Canyon site. This is our reference site. So this is saying that this is the site that we are basing all of these other measurements on. And we chose that because it's the most pristine and untouched site that we have. And so we figured that would be the best reference for what a typical community in the Wasatch would look like without human impact. And then what we can show is how that site development changes or alters the community structure. What type of mammals we see at a site has a direct correlation with how much development is measured by the community scientists at the site. So this is just another measure that we can use to assess how wildlife are changing or reacting to the development that we see across the central Wasatch. When we look at that on a species level, we can start looking at these exact same things, but not just looking at how it affects a community, but how it affects the entire or each individual species. And so this is that same measure, site development index, that we're looking at here. On the y-axis, we see coefficient. This means basically the effect that site level development has on each one of these species. And so we see that if it's an orange dot and then the confidence intervals don't overlap with 0, that's a negative effect, that site level development negatively affects elk. On the flip side, if we had something where, let's say, beaver or raccoon was above this black line here, and it had a black dot, that would mean that site development would positively impact raccoon and beaver. But so what we see here is that we have a pretty stark negative trend in site development for most of our species. And in fact, some of those are statistically significant. And then what you'll see here is this gold bar. This is the community average. And so right here, this is the average across all of the species. And these bars, or this band, is the 95% confidence intervals for the community effect. And so what this is saying that there's a net negative effect, but it's not statistically significant because it does not, it overlaps with 0. And a 0 in this case means that there's a net zero effect, that there's no effect of this parameter on any of these species. And so although it's not statistically significant, we do see that there is a net negative effect for the entire community, and we can see that manifest itself in the negative effects on specific species. We can then look at stuff like dog presence or cat presence. And dog presence is actually really reassuring. I like to walk dogs, and I like to have them in the canyons. And so I was a little worried to run this analysis, but it worked out, luckily enough. There's really no effect of dog presence on any one of these species. And when we look at the community effect, it's net positive, but that's basically about as close to 0 as it gets, where the confidence intervals really overlap the entire parameter space. And so, dogs really don't seem to have much of an effect on most of these species. But interesting enough, domestic cats do seem to have some type of an effect. So there's actually a statistically significant community effect. So that means across all of the species, the entire community is reacting negatively to the presence of a domestic cat in the area. Even though only one species, in this case bobcat, which is also very interesting, has an actual negative effect, a species level negative effect. And so this is just another way of showing you how we're analyzing this data. And we've done this for a lot of different parameters for, like I said, all the species that you see here. These were just some that I thought would be interesting for everybody involved. Then another one I thought would be really interesting to show is hiking traffic. A lot of people are worried that the increase in hiking traffic could potentially negatively affect wildlife. And I was one of those people, but we actually are corroborating evidence from North Carolina here, showing that hiking traffic really does not have much of an effect on most of the species that we see. And in fact, that community effect is about as close to 0 as possible. It's right on that 0 line. And so really hiking traffic doesn't seem to be negatively affecting any species, which is, good news for us hikers and good news for us people that like to go out into the wilderness. One of the last figures I wanted to show is this idea that I-80 is really having an effect on our community. This is actually data from a project that we ran right after 2019's field season ended. If you worked on with us on 2019, you heard me talk about Kelsey Barnick and her project looking at the difference in communities both north and south of I-80. Well, her project is wrapped up now, and we've been able to analyze that data. And these are the two big findings. And really, they're pretty stark. So what you're looking at here is the estimated species per site. So this is that species richness estimate. And you're looking at the differences between north and south of I-80. And this is a very stark difference, where north is having a statistically significant number of species, at least a greater, than the south. And then we can also see that that community similarity index, so basically the wildlife community that composes those sites, both north and south, is statistically different from one another. And so these are pretty stark changes that we're seeing in response to this interstate highway. All right, so those are just a snippet of some of the past results that we are getting, and we're starting to write these things up. There are many more that we're working on, and even stuff that I wasn't able to show you. So if you're interested, feel free to contact me and I can share every single thing we've done, but I just thought that those are some of the most important things. And so thank you for watching this video, and I hope you tune in to the rest of the videos.